Right, so we're going to start by doing some practice with division, long division with polynomials. So let me write a division problem. So we have 2x to the third minus 5x squared plus x minus 8. And we're dividing that by x minus 3. So before we go through this process, this should be plus, not plus 8 minus 8, plus x minus 8. So before we go through this process, we call this kind of fraction. This is an improper fraction. Why would we call this an improper fraction? Anybody have an idea? It has to do with the degrees. So how do the degrees compare? They're different? The degree on the top is bigger. So the degree on the numerator, I'm going to say degree of the numerator is greater than the degree in the denominator. So when the degree of the numerator is greater than the degree of the denominator, we have an improper fraction. Just like when we have numbers and the number in the numerator is larger than the number in the denominator, we have an improper fraction with numbers. Same idea. All right, so let's go through this process of doing this division. So long division, very easy, very algorithmic. You shouldn't be afraid of it. It's not that bad. X minus 3, I'm going to set it up just like we do did division problems in elementary school. And the way I do this is I say, what do I have to multiply x by to get 2x to the third? 2x squared. Write that up here. Multiply this by both of these terms. So I get 2x to the third minus 6x squared. One place that a lot of people make mistakes is we subtract here. We're subtracting this entire quantity. So we end up with sign errors in here. So I end up with a 0 here, negative 5x squared plus 6x squared is x squared, and then I bring the x down. If I bring this straight down. And now I say, what do I have to multiply x by to get x squared? Write x there, multiply that out, x squared minus 3x. Remind myself that I have to subtract. I get a 0 there, x plus 3x is 4x, and I bring the minus 8 down. And then I say, what do I have to multiply x by to get 4x? And I multiply those out, so I get 4x minus 12. And I subtract, and I get 8 plus 12 is negative 8 plus 12 is 4. So what this tells me is that 2x to the third minus 5x squared plus x minus 8 divided by x minus 3 equals 2x squared plus x plus 4 plus 4 over x minus 3. Yes? That means that x minus 3 is not a factor, because if you remember doing this before, when we divide by a factor, what's our remainder? 0. And that's really what we're getting at in this particular section, is finding these zeros, using division to find zeros. And the other nice thing is, if my remainder is 0, I've reduced the power on what's left by 1. I started with a cubic. If I divide by a factor, I'm left with a quadratic. We have lots of tools to solve quadratic equations now. We can factor, we can use a quadratic formula. So this lets me find all of the zeros of my function if I can find some zeros. And later on we'll talk about how we narrow down what those zeros can be, because a lot of numbers could be zeros of that numerator. All right, so before we talk about the technical stuff, so we have this procedure. What happens? What if I have this written out, and let's say I was missing the x squared term? What do I have to do if I'm missing the x squared term here, the thing that I'm dividing? We have to put a 0 x squared. We have to put a placeholder in. So if we have an x squared, we have to have all of the places for all of the powers of x. X to the fourth, if we have x to the fourth, we have to go x to the fourth, x to the third, x squared, x in our constant. If any of them are missing, we have to put a placeholder in for it. That's another place that a lot of people make mistakes. If they're out of order, we want to rewrite them in descending order of the powers of x. So we always start with the highest power and go in decreasing order for the powers of x. And we will do another example of long division in just a second with a different type of divisor. But this leads us to the technical details here is called the division algorithm. The division algorithm basically guarantees us that if we have an improper fraction, we can divide and find the things like we just did. So I'm going to say f of x and d of x are polynomials. And we're talking about polynomials here. So f of x divided by d of x is an improper fraction. The division algorithm guarantees us that we can find a q of x and r of x, other polynomials, so that, and I'm going to say f of x over d of x equals q of x plus r of x over d of x. So as long as we have an improper fraction, the division algorithm tells us we can always find these quotients and remainders. And the other way that I could write this out, if I multiply everything on both sides by d of x, I could rewrite this. Sometimes you'll see this written q of x times d of x plus r of x. So I'm just multiplying this all out. And we give special names to all of these things. So I just want you to see these names because you'll see them come up. They'll talk about these things. F is the dividend. D of x is the divisor. Q of x is the quotient. And r of x is the remainder. So when you see those words, I just want you to know the book likes to use the technical terms. You might be asked about the quotient or the remainder, the dividend. I just want you to have some idea of what those terms mean. So the division algorithm guarantees us if we have an improper fraction of polynomials, we can always do do our division and find these other polynomials, the quotient and the remainder. That's what it guarantees us. So let's go through another long division example, and then talk about synthetic division. So a lot of times people get worried when they see something like this 4x, and I'm just going to do the division here. 4x to the third minus 7x squared minus 11x plus 5. All right. So what's the first thing that goes on top here? X squared. Multiply those out, so I get 4x cubed plus 5x squared. When I subtract, what do I get? Minus 12x squared. And I bring the 11x down. All right, what's the next thing that goes up here? Minus 3x. And I multiply that out, I get minus 15x. Subtract. What am I left with here? Negative positive 4x plus 15, right? So plus 4x, okay? Bring down the 5. All right, what goes in next? Plus 1. And I get 4x plus 5, remainder 0 when I subtract. So what does that tell us about 4x plus 5? It's a factor. What else does that tell us about 4x plus 5? What can we do with 4x plus 5? What would be a solution to 4x cubed minus 7x squared minus 11x plus 5? Negative 5/4 x would be a solution. So it would also be what for the graph? A 0 or x-intercept, right? Factor, 0, x-intercept, solution, all mean the same thing. So there's a process that simplifies this procedure in certain cases, synthetic division. So it speeds things up and it makes this process a lot faster. This is not a difficult process. There's a lot to write, a lot to keep track of. But it's not difficult. Synthetic division gives us an easy way to work with these things in certain cases. So let's talk about synthetic division. All right, and we're going to do synthetic division. We'll do an example. But synthetic division is only works when we are dividing by something in the form x minus c. So only when we're dividing by something in this form. We can't use synthetic division in any other case. So in the last example we did, we could not use synthetic division because we had that 4x plus 5. So only when we have something in the form x minus c. So let's look at an example of how we're going to set up synthetic division. I know you guys have seen this before, so I'm not going to go spend a lot of time on how to set it up. So we have 3x to the third minus x squared plus 2x minus 3, and we're dividing by x minus 2. So what we do for synthetic division is I'm just going to write the coefficients. I need to make sure that my powers in x are in descending order and that I put a 0 in for placeholders for any that are missing. So I'm going to put a 3, negative 1, 2, negative 3. I like to do it with a little bracket. And then we put just the c here. So for this case, it would be 2. I bring the 3 down, multiply, then add. $21. This is my remainder. The last number is my remainder. So that tells me that this quantity equals my exponent is reduced, my power is reduced by 1. 3x squared plus 5x plus 12 plus 21 over x minus 2. And again, if my remainder is 0, then x minus 2 is a factor of the equation. X equals 2 is a solution. X equals the graph would cross the x-axis at x equals 2. So all of those things would be true. So the important thing to remember about synthetic division is we can only use it when we're dividing by x minus c. Yeah.
Could you use it in the form of using the last question if you just multiplied or divided all of the on the top? 3 negative 1, 2, negative 3. You just multiply the denominator accordingly.
So let's see. If we, I think, let me make sure. So you're asking here, if we wrote this in the form x.
And then you divided 4, negative 7, negative 11, and 5 by 4.
Yes, I believe so. Or if we wrote this x x plus 5/4, we could do it that way, which would accomplish the same thing basically. So we could write this in the form x plus 5/4 and do it that way. You could end up with messy fractions, but it'd be possible, yes. Okay. All right, are we good with the synthetic division, the process of the synthetic division? Do we need to see another example of synthetic division? Yes? Okay, let's do one more example. All right, we have 8 plus 6x plus 5x to the third, and we're dividing by x plus 2. All right, so when we set up our synthetic division, what are we going to write? How are we going to write our numbers? 5, 0, 6, 8. Yes?
I don't understand where you get
The 5 comes from here. The 0 comes from the x squared term. There's no x squared term, so that's a 0. The 6 comes from the x term, and the 8 comes from there. Okay? And what do I write out here? Negative 2. Bring the 5 down. I get negative 10. Add those, and I get negative 44. So this tells me that this equals 5x squared minus 10x plus 26 minus 44 over x plus 2. Synthetic division, very nice for long polynomials. You can do division very quickly because you're just multiplying and adding. Now you can get very large numbers depending on the polynomial, but because we're just multiplying and adding, it's usually pretty not too bad to do the arithmetic. When you start having fractions in here, then it can get kind of ugly. But synthetic division, nice quick algorithm to use for dividing polynomials. All right, I want to talk quickly about how we're going to use synthetic division, how we're going to use long division when we're dealing with polynomials. And then most of tonight's homework, I was hoping to get through more, but I think I'm just going to stop in just a little bit and we'll talk about the rest of this section on block day. So the way we're going to use synthetic division, we have two really important theorems that tell us about how we're going to use them, or use synthetic division and long division. One is called the remainder theorem. And we've talked a little bit already about the remainder theorem. We said if we do the division and the remainder is 0, then we know that we've divided by a factor. Well, the remainder theorem tells us a little more than that. So f of x is a polynomial, and we are dividing by x minus k, so x minus some number k. I'm going to say if out here in front. If f of x is divided by x minus k, the remainder is f of k. If we're dividing by a factor, we said the factor and a 0 mean the same thing. So f of whatever number that is a factor turns out to be 0. So if our remainder is 0, then we're dividing by a factor. So let's look back at our other examples. Here we're dividing by x minus negative 2, so we're k is negative 2. So this tells me that if I plugged negative 2 into this function, f of negative 2 is negative 44. The remainder is negative 44. I divided by x minus negative 2. So f of negative 2 is negative 44. If I go back to this example, we divided by 2. So f of 2 by the remainder theorem is 21. Because my remainder is 21. And I can do the same thing here. F of negative 5/4 is 0. So that's what the remainder theorem tells us. Is whatever the remainder is the value of the function at this number k. The remainder theorem, we can use a remainder to evaluate functions. Sometimes it's easier to do synthetic division than plug in those numbers and calculate all that stuff out, because we're just multiplying and adding. But the way we really want to use the big way that we use a remainder theorem is by connecting it to the factor theorem. And we've already talked about the factor theorem as well. So we have f of x is a polynomial. Has a factor x minus k, if and only if f of k equals 0. So factor, solution, 0, we've talked about that already before. So the way we connect these two is we do long division, we do synthetic division. If the remainder is 0, then we have divided by a factor. So that's usually how we use the remainder theorem and the factor theorem. If our remainder is 0, we know we've divided by a factor. And what we'll do on block day is we will figure out, by looking at the polynomial, how we can narrow down what factors of the polynomial might be. How we can figure out some good guesses to do synthetic division with, to find our zeros, to find our factors. So what the homework today mostly is doing synthetic division or doing long division, and verifying. The questions might ask you to verify that you have a factor. To verify you have a factor, you divide. If your remainder is 0, then you know you have a factor. I think there's one question at the end that asks you to then completely factor the polynomial. So let's look back at this example. Where was it where we had a remainder of 0? So here's where we divided and we got a remainder of 0. That tells us that 4x plus 5 is a factor. So we have one factor. We are left with, so let me write this out. I'm going to say that 4x to the third minus 7x squared minus 11x plus 5 divided by 4x plus 5 equals x squared minus 3x plus 1. We know that 4x plus 5 is a factor. How can we then find the remaining factors of this function if we're left with x squared minus 3x plus 1? What's that? Factor this. We can factor this. If we can't factor it, what could we do? What always works for quadratic function? Quadratic formula. So if we want to find the remaining factors, we factor whatever's left. Because when we divided, this is all that's left. Factor whatever's left. And you have all of the factors of your function. So you find, if you have one factor, you've reduced the power when you divide. Find the factors of what's left, and you've found the factors of your function. So I think there's a couple of questions at the end that ask you to do that. Find the remaining factors. So you just factor whatever's left. All right. Homework. We're on page 125. I'm cutting, it's not what's on the board, I'm cutting that kind of in half. So there we go. There might be some questions in the very